Alrighty, this is going on page 47 when we're done. We're going to talk about the fundamental theorem of algebra, and in order for us to get through that, we have to talk about complex zeros. Do you remember doing complex numbers? Does that sound familiar to you in any way? Okay, so what does complex numbers mean to you? The thing with the eyes, so what are those called? Yes, so they're imaginary numbers, right? So what does I equal? Oh, close. Square root of -1. Good. So I is equal to the square root of -1. Make sense? Remember that? Okay. So those are imaginary numbers. And so this says, just as polynomial functions can have real zeros, rational or irrational, and we've been through both, they can also have complex zeros or imaginary zeros. So we're going to find all the zeros of these functions and simplify anything that's irrational. So let's start with number 1. And is this something that we can factor? And each numbers are going to multiply to give me 12 and subtract to give me 4. Yes. Okay, so it's factorable. And even if you don't love factoring, it's better than any other option. So we want to go with that first if possible. So this is x to the 4th, so we get x squared and x squared. This is negative, so one of them is positive, one of them is negative. What's my positive number going to be? 2, and then negative would be 6. Okay. So at this point, can I factor this anymore? No, because this is the sum of something, and so no with the squared. And this is not a difference of squares. So as far as we're concerned, this is as far as we can factor it right now. Then we can find the zeros, right? So here, this means that x squared plus 2 equals 0, and x squared minus 6 equals 0. This is probably the last time I'll actually write out the equals 0 part of that, because I think you know that you can kind of skip to the next part. So we get x squared equals -2. Then I'm going to take the square root of both sides. So I'm going to get x equals the square root of -2. Do you agree with that so far? What? Plus or minus. Thank you. Plus or minus. You still have to have the plus or minus. Don't forget that. Okay? So then I can't take the square root of 2 like that's going to stay, but that negative is going to come out as what? I, because the square root of -1 is I. So this is like the square root of -1 times 2. So x is really equal to plus or minus I times the square root of 2. Now, when you have like 3i, usually I comes last. But with the square root, I highly suggest it comes before the square root, because sometimes you can't tell if it's underneath there or not. Does that make sense when your little square root sign gets a little crazy? All right, so then over here, this means that x squared equals 6. So what does x equal? Good. Okay, good. Plus or minus the square root of 6. Don't forget the plus or minus. So that means that my zeros here are plus or minus I times the square root of 2 and plus or minus the square root of 6. And when you have the plus or minus, I mean, which one comes first? You could argue it either way, so it's fine. Everybody good so far? Remember the imaginaries, yes? All right. So let's look at number 2. We're going to factor this one. So if we factor this by grouping, 4 times 8 is 32. So those two numbers would have to be 32 and 31. So we're going to get 4x to the 4th plus 32x squared minus x squared minus 8. Do you agree with that so far as grouping is concerned? All right. So then we get 4x squared times x squared plus 8 minus, and then factor out a -1, and we get x squared plus 8. Now, this is not fully factored. This is one of the places that some of y'all stop and think you're factored all the way, and you're not. It's got to become 4x squared minus 1 times x squared plus 8. But then still, could I factor this more? Yes, because that first one is a difference of squares. Good. So this is 2x plus 1 times 2x minus 1 times x squared plus 8. And that's the best I can do right there. Right? So that's as much as I can factor it at this point. Then I'm going to find my zeros. Well, here, I know this is going to give me x equals -1/2. This gives me x equals 1/2. Then this is going to give me x squared equals -8. So x equals plus or minus the square root of -8. So that negative is going to come out as what? I. And then I have to simplify the square root of 8. What does that simplify to? 2 square root of 2. Good. Excellent. Wrote 2 there. So this is going to be plus or minus 2I times the square root of 2. You wouldn't put the I before the 2. It wouldn't make any sense there. All right, so that means my zeros in the end are plus or minus 1/2 and plus or minus 2I square root of 2. What would you do if it wasn't 2I? If it was I2, it wouldn't be wrong. It would just be weird. Does that make sense? Like I wouldn't count it wrong, and just kind of want to get it to that. Because technically it kind of comes last, kind of like the x. Even if I did x2 instead of 2x, it wouldn't be wrong. It'd just kind of be weird. Same kind of thing. Good question. All right. Any questions at this point? Anything else? All right. So number 3, I want you to do that one 100% on your own. You can do that. Sorry, me too. It feels like a Monday and it's never good. Okay, so do you agree with me? Yes. Okay, so let me ask you this. At this point here, could I have stopped here and found my zeros? Yes. Okay, and so this gave me x squared equals negative 4. This part would have given me x squared equals 4, and then what would x equal? Okay, so I heard plus or minus 2, and I heard 2. The 2 is where the problem comes in, right? Because it's plus or minus 2, which is what you end up getting, right? But a lot of times, we forget to do the plus or minus, right? But when I say I want it factored completely, or fully factored, and then do it, that's why you need to get to this point. Yes, you could get your zeros here, and if it just says find the zeros, whatever. But if I'm telling you I want to see it completely factored and find the zeros, then you have to make sure you take it to the next step. Okay, does that make sense to you? Because I'm not sure that we all still understand what completely factored means. And we're about to factor even more. All right, so let's look at number 4. When I want to try to factor this, what should be the first thing I do? There you go, GCF of negative 2. So negative 2, and then that leaves me with x cubed plus 8. So at this point then, can I say that x cubed equals negative 8 and then take the cube root of both sides? No. Sorry to burst your bubble, but no. It doesn't work the same way as it does for squares, okay? Can I factor that more? If it's a cubic, your choices are grouping, which that isn't going to help me there at all, right? Or sum or difference of cubes, and not quadratic formula because it's not a quadratic. There you go. There's not a cubic formula. But you have sum or difference of cubes. Is this a sum of cubes? Yes. What's the cube root of 8? 2. So I can take the cube root of both, which means it's a sum of cubes, right? Which is not that big of a deal to factor. So we've got, this is equal to, so I have my negative 2 out here. When you have the sum of cubes, you're going to have a binomial and a trinomial that factor out. Then your signs come from SOAP, okay? Same, opposite, always positive. This is the sum of cubes. So your signs are the same, opposite, always positive. That's what that means. That's where the signs come from. Build it. Don't just try and write it down left to right. Put your parentheses, put your signs in there. Then we fill in the numbers. So to find these two numbers, I take the cube root of both. Well, the cube root of x cubed is x. The cube root of 8 is what? 2. So my two pieces are x and 2. To fill these 3 spots in, I take this first one and I square it, so I get x squared. The second one, I multiply these two together and I get 2x. The last one, I square this one and it's 4. You see how easy that is to build instead of just saying, oh my God, I don't know how to do this. You write it stuff down, get your soap, get your signs in there, and then just do it piece at a time. Okay? Okay, but now we should be able to do it, right? And if this was x cubed minus 8, then this would have been negative, positive, positive, right? Because soap, same, opposite, always positive. All right, so now when you factor a sum or difference of cubes, the great majority of the time, this doesn't factor anymore. Like we can check this and see, but sometimes it's hard to check and you're not sure. But two numbers that multiply to give me 4 that are going to combine to give me 2, like those just don't exist. So we can't factor that anymore. But that doesn't mean we can't find our zeros. When we go to find our zeros, does this negative 2 affect that at all? No, it does not give me a 0 because there's no x on it. When you have something out in front by itself, it's only if it's a variable, and it's not. So that negative 2 doesn't affect anything. It just got divided out. So I'm only looking for the zeros within these two. So this will give me x equals negative 2. And then since this doesn't factor, what can I use here? Now I can use the quadratic formula because it's a quadratic, okay? So x equals negative b, so that's a positive 2, plus or minus the square root of b squared minus 4 times a times c, all over 2a. I highly suggest your first step is just to write it down because the signs are what gets you messed up in here. And if you're trying to do the math in your head, the signs are where you mess up. So then this is equal to 2, plus or minus. All right, so negative 2 squared is 4, minus 16 all over 2. So what's 4 minus 16? Negative 12. Plus or minus the square root of negative 12 over 2. So I've got the square root of a negative 12, which means an I is going to come out, right? And then I have to simplify the square root of 12. What do I do when I simplify that? 2 and 3. So it's be 2i square root of 3 all over 2. Then can I simplify this? Yes, I can cancel out all the 2's. Does that mean that this becomes a 0 right here? No, it does not. This is equal to 1 plus or minus I times the square root of 3. That's what you get out of that quadratic formula there. Yes, don't forget to put the 1. Well, when you do this then, okay. So here's how we don't forget that. When you cancel these out, since there's something left here, like when we cancel it out, it's because 2 goes into 2 once, 2 goes into 2 once. Put the 1 there, just like you would if you were reducing something else. Write the numbers there. Then here, obviously, you're not going to put 1 on the bottom, and you know that. You're not going to put this 1, but this, maybe that would help you not forget to do that. Because I think that is what happens. Y'all cross them all out, and it's like it completely disappeared, but that's not really what's happening. Okay. All right, so now my zeros then are negative 2 and 1 plus or minus I times the square root of 3. What questions do you have? Okay, so that's kind of a quick review of your imaginary numbers. So let's talk about what the fundamental theorem of algebra says. This says a polynomial function, so that's what we've been dealing with, of degree n, those are all the ones we've been dealing with, where n is greater than or equal to 1 has at least one, what's the word I want? There's a 0. They're not useless. Yes. 0 in the complex number system. That stuff will come back up. It will surprise you. At least 1 0 in the complex number system. So I want you to think about that. Okay, a polynomial function of degree n, where n is greater than or equal to 1. So all that means is you have a polynomial. So your polynomial could be like f of x equals 2x to the 8th plus 4x to the 7th minus 2x plus 3 or whatever. That's a polynomial of degree 8, right? So your n would be 8 there. Okay, so what it's saying is any polynomial you have where n is greater than or equal to 1, well, it kind of has to be, then it has at least 1 0 in the complex number system. So think of all the polynomials we've done. We found all the zeros and stuff. Well, if we're thinking about complex numbers as imaginary numbers, have we had imaginary zeros in every single thing we've done? We haven't, right? We haven't even talked about them until today. Now, could they be there? Yes, absolutely. If I graphed this and it looked something like, I don't know, this or whatever, then I only have 1, 2, 3, 4, so maybe the other 2 are imaginary, or, you know, or the other 4 are imaginary, whatever. But complex numbers do not equal imaginary numbers. This little statement right here says, any real number is also a complex number. So although the term complex number didn't really come up until you started learning imaginary numbers, that does not mean imaginary numbers are the only complex numbers that exist. So here is a Venn diagram of your number system, okay? So the big brown oval there says complex numbers. That's pretty much all the numbers you know. And they're in the form a plus bi, right? Like 2 plus 3i, whatever. So we have imaginary numbers over here. A plus bi, that 2 plus 3i, whatever like the ones we just found. Pure imaginary numbers is where it would just be like 2i. It doesn't have the other part in front of it. But your real numbers and this system, which we've been working in mostly so far, are still complex numbers. The difference is b is 0. So the number 2 is a complex number. Written as a complex number, it's 2 plus 0i. We just don't write it that way because it would be ridiculous, okay? So a whole number that you know, all of these numbers right here, they are complex numbers. Your natural numbers are your counting numbers, like 1, 2, 3, your whole number, 4. Good, very good. Your whole numbers add 0 to that, 0, 1, 2, 3, 4. Your integers add the negative ones, so -2, -1, 0, 1, 2. And then rational numbers, they can be written as fractions, decimals. And then you have irrational numbers kind of by themselves. These are pi. Thank you. Pi is a good one. So here, all of these are real numbers, but could still be written as complex numbers. So I want to make sure that you understand the fundamental theorem of algebra, because it seems kind of ridiculous if you're not really comprehending what it's saying. No. Well, infinity is not a number. Sorry. All right. So that's a good question, though. Are there numbers that are not complex numbers? I'll see how I'll come up with some examples for you for that later on. Okay. All right. So, but not right this second. Yeah, exactly. You'd be like, you can wow them with your knowledge of numbers. Mm-hmm. Or, there you go. Or Jeopardy one day. You never know. Never know. You might be on Jeopardy and they ask you one of those theorems you thought were so useless. And you'd be like, hey, look at me. I know my geometry. There you go. See? There you go. You're a millionaire now. All right. So a polynomial function, because here's the thing. One thing that could possibly happen to you, will most likely happen to you in college, and it may not just be in a math class, is you're going to have to read theorems or statements like this out of something, and then you're going to have to make sense of it when it seems like ridiculous, kind of like this sounds. So so make sure we know what a polynomial function of degree n is, and then it says it has at least 1 0 in the complex number system. So now what you know about complex numbers, pretty much they're all the only numbers you know of. Well, doesn't it make sense that it would have to have at least 1 0 in the complex number system? And wouldn't it have to have all of its zeros in the complex number system? Because what else would they be, right? So why do we even say it this way? Well, it has to do with, what if I just had f of x equals x to the 5th? Where does this cross the x-axis? At the origin, right? And it's going to look like, because this is a power function, doesn't have anything else going on with it like that one does, it's going to look like a cubic, right? It's just going to be skinnier. So this, because it's x to the 5th, it has 5 zeros. But guess what? They're all 0. It's just that same one repeated over and over again. That's why it says at least 1. Because wouldn't you think, well, this is to the 5th, don't I have to have 5? Well, but it's x to the 5th, there's 0, 5, it has a multiplicity of 5. So the reason it's stated that way is because of the multiplicities, right? Little bit of a side note here, because this came up on the PSAT stuff on Friday, so I want to make sure that I answer this question. One of the questions that came up, somebody asked me, what does it mean? What is a double zero? Like, I don't even know what that is. So I said, well, it's like a double root. And then it occurred to me that I hadn't used those words with y'all. So I knew she knew how to do this problem. But because it was asked that way, she didn't know what the heck they were talking about. And it's not a term that, you would necessarily have to have for calculus or whatever. I just didn't realize that it was, important that I actually say them this way. So again, kind of side note from what we're doing today, but if I don't say it now, I'll forget. So if we have a function and it's like x plus 2 squared times x minus 5 cubed times x plus 1 or whatever, right? So we know that this is going to be a 6th degree polynomial. Do you agree with that? All right, so these roots here, when I find my zeros, I have 1 at -1, 5, and then I have -2. But then we have these multiplicities here. So because the multiplicity is 2, that makes this a double zero or a double root. That would make this a triple zero or a triple root. Does that make sense to you? So when we talked about multiplicity, I just didn't use those words, so it seemed like something that it was brand new. And then the question had pictures that were like, I don't know, something like that, and then something like this. So it was asking, and it didn't have a function there. It just said which one of these graphs or which one of these polynomials has a double root. So when you look at this, well, the multiplicity being even means what when we're graphing it? That's your balance. That's where it's tangent, right? So if these are my choices, and I said which one of these has a double root, then this is your answer, because what they were getting at is you understanding the multiplicity and the tangency part of that. The other thing is, if I give you this doesn't guarantee that that is just a double root. Couldn't that be a quadruple root? It just means that it's even. But based on how that question was asked, because those were your only choices, then it made sense for that one. Okay, we good on that? Just want to make sure I kind of went over that with everybody while I was thinking about it. All right, so let's flip it over on the back. Linear factorization theorem. So we thought we had things completely factored, but we really didn't every single time. So this says if C is a complex zero, which means basically if it's a zero, you're able to find, right? Because they're all complex. Of a polynomial function, then x minus c is a linear factor of the polynomial. Which we've had that exact same statement before, right? The difference is we weren't dealing with the imaginary numbers on this, and we can't factor those without actually finding the zeros. So this says that this means that all polynomial functions can be completely factored. We may not always factor them all the way, maybe not always ask for that, but when we've gotten to a point on some of these, like before if I had asked you, all right, let's go back to this one. So when we get here, say, can I factor this anymore? Your answer's like, nope, sure can't. Well, the truth is we can. We just couldn't with the skills that we had at that time. Does that make sense to you? So this was as far as we could get with what we knew how to do. But now we're going to be able to take it a little bit farther. Right? So the directions say find the zeros of the function, then find the complete factorization of the function. And this time complete means complete. So before when I've said fully factored, it was like fully factored to your abilities at this point. But now we're going to be able to do it completely. So we start by finding the zeros, which means I want to start by factoring if I can. So this is x to the 4th, so this will be x squared and x squared. Two numbers that multiply to give me 25 are going to be that 25 and 1. And is 25 positive or negative? Or it was, okay, this is a negative and this is a positive. And then I can factor this, so this becomes x plus 5, x minus 5, and then x squared plus 1. That's the best we can do at this point. So then I find my zeros, like it tells me to do. So this gives me x equals negative 5, x equals 5, and here x squared equals negative 1, which means x equals plus or minus the square root of negative 1. So x equals plus or minus what? I. Very good. So there are my zeros. So I state my zeros. X equals plus or minus 5 and plus or minus I. So now that I have my zeros, now I can, for real, completely factor this thing. And it's going to look like this. F of x equals, it's going to be x plus 5, x minus 5, and then x plus I, x minus I. That is the true complete factorization, which looks a little weird, but we've taken into account the imaginary numbers and everything. Okay? No, it's not that much. No. Because basically, you know how to find the zeros. We're just now putting it back in the factors. That's it. Okay? Because I couldn't really factor it without knowing what they were. Go ahead. Okay. It's okay. It's okay. Michael thinks differently than we do, and that's okay. He thinks outside the box. And yes, exactly. So what? Okay, I see where you're going. You're multiplying it back together, right? So when you do this, yes. So when you're multiplying these two together, this is a difference of squareds. So you do get x squared minus 25, right? So here you get x squared minus I squared, right? And then I squared is negative 1, and when you subtract a negative 1, that's why it becomes x squared plus 1. Very good, Michael. See? It's all good. Does that make sense to you, how you kind of work? Because we're going to be working backwards like that tomorrow, so that is something you need to be able to process for sure. All right, so look at number 2. Does it look just like number 1 on the front? Heck yeah, you didn't even look. But it does. So we're not going to factor again. We're just going to say C front, because we didn't necessarily need to do it, because we already did part of it, right? We found the x's. We get plus or minus the square root of 6 and plus or minus I times the square root of 2. That's what we got from number 1. So we don't need to do the work again to get there. But we stopped there on the front because all it said was find the zeros. Now when we want to have it actually factored, that means that f of x is going to equal, well, we will have x plus the square root of 6 times x minus the square root of 6 times x plus I square root of 2 times x minus I square root of 2. Yeah, just using those zeros there. Okay. Everybody okay with that? So it looks weird, but that's okay. Because again, this is a difference of squares. So this would give me x squared minus the square root of 6 squared, right? What's the square root of 6 squared? 6. So this is x squared minus 6 was one of those factors. Okay? Yes, completely. And you won't, and moving forward, you won't always be asked to do it completely, because we may not be interested in the imaginary numbers some of the time, and that's okay. You know, getting to the other factoring would be enough, but we do need to know how to do this and when to apply it. All right, so let's look at number 3, because a few different things happen in some of these we want to look at. So this one does not match one on the front, so we're going to factor it. If I'm going to do grouping, 9 times negative 4 gives me that negative 36. So I get, 36 and negative 1, but yes. Plus 36x squared minus x squared minus 4. This gives me 9x squared times x squared plus 4. Factor out the negative 1. You get x squared plus 4. 9x squared minus 1 is x squared plus 4. Oops. Then this is the difference of squares. So I get 3x plus 1 times 3x minus 1 times x squared plus 4. So without finding the zeros, that's really the best we can do at this point. You'll kind of get to the point where you could recognize the rest of it too. But we find our zeros. So x equals negative 1/3, x equals 1/3. And then x squared equals negative 4. So x equals plus or minus what? 2i. Huh? See? The I. You got it. So f of x is equal to, I'm sorry, I need my zeros first. Back up. I got ahead of myself there. X is equal to, we get plus or minus 1/3 and plus or minus 2i. Oh my gosh, it's not a parenthesis. Okay, so there are my zeros. But here's what we don't do. Notice right here, with these, we just took whatever these were and we put them right into these little, we just plopped them in there. But what we are not doing here, even though it's plus or minus 1/3, if x equals negative 1/3, I do not do x plus 1/3. That's a big fat no. Okay? Yeah, you have to do 3x plus 1. You're going to have to think about where it came from. So from here, then I would multiply both sides by 3, so I get 3x equals negative 1, so it's really 3x plus 1. Like, you don't have to go through all those steps, but that's where it's coming from. It's like, where did that 1/3 come from? Those should never be fractions. They may not always be whole numbers because of situations like this, but they're not fractions. So your f of x, when you factor it then, where did that 1/3 really come from? We get 3x plus 1, 3x minus 1, and then x plus 2i, and x minus 2i. Mm-hmm. Pretty much, yes, absolutely. Well, not imaginary or irrational, because here, although the work is on the front, we got that by doing it differently. So yes, if you already have a factor there and this is where it came from and it was like one of the easy ones, then yes, it's the same factor you had. All right, what other questions are there? All right, so I want you to do number 4. All by yourself. Okay, you all agree with me so far? So is this last thing x plus 5 or x minus 5? Minus, because that's how you get the zeros back there, right? On the other ones, they were all plus or minus, so if you've got them backwards, it didn't matter. But when there's 1, it definitely matters. All right, what questions do you have? Yes, sir. Huh? Yes, but you might want to listen to this real quick first. So one of the things that I want you to do in addition to this assignment is in your Google Classroom. So go here. Okay, so when you go to Google Classroom, it looks something like this. And I'm probably not going to do a whole lot in here until second semester because I'm still kind of learning, but there's a lot of things I really like about this. But I did put one little assignment in there for you. When you go to classwork, so when you're in your stream, you go to your classwork. And so this is what it'll look like. And over here on the left, this is kind of like folders. So I have the calendar in here, so you can get to the calendar that you see every day if you need to see that. The YouTube playlists, the links to those. And then this would be like the blank copies of notes and homework. I haven't gotten that far yet. But all the same stuff that's in Schoology. Like you can still find all of this in Schoology except for the assignment that I put in there. And I did even put a due date of like Friday at midnight. And you can even look at the Google. So this calendar and this calendar is different. If you go to the Google calendar, then it should show you on Friday. Oh, ask me later. It should show you on Friday, but it doesn't. Oh, because it's not until midnight. That you have something that's actually due down there. But you don't have to look at it that way because it'll be on the other calendar. But anyway, when you're in here, there's this thing that says Delta Math. All you have to do is get signed in. And I know I've had you sign into some other things we haven't done yet, but Delta Math has some really, really good practice problems that are online. And a lot of times the online stuff is kind of junk, and it's totally different than Khan Academy. But when you click on Delta Math, there's instructions. I know you can't read up here because it's too small, but it tells you to click on this link below. This is the link. And then it tells you how to create the account, because it's one of those that you can't sign in with Google, like you have to create it. But to use your district stuff, I give you the teacher code, whole 9 yards. Make sure that you actually do the class period and MAV time. When you choose them, they'll put little check boxes. Just get signed in by Friday at midnight, and it'll be 100 for homework grade. Okay? It's that simple. You can get in your tablets and do that now if you want to. You don't have to, but, that way if it doesn't make sense or something, you're good. Okay?